All right, welcome back. Today we're diving into something that is, and I'm not exaggerating here, the absolute foundation for pretty much anything you'll ever do in Azure. We're talking about building your private network in the cloud, and the star of the show is the Azure Virtual Network. So, let me ask you this. Why is it that when you create new resources in the cloud, they're basically like lonely, isolated islands? You've got a brand new virtual machine over here, a database over there, but they can't see each other. They can't talk to each other. What's up with that? Well, believe it or not, that isolation is actually a feature, not a bug. It's all about security right out of the gate. But it's not super helpful when you need your web server to actually connect to your database, right? So for these islands to become a thriving ecosystem, they need a safe, secure way to communicate. So what's the solution? How do we build those bridges between our islands? We don't just build bridges, we build our own private secure ocean for them to exist in. And the tool we're going to use to do that is the Azure Virtual Network.
Okay, so what is an Azure Virtual Network, or VNet as you'll hear it called? Think of it as your own private, carved-out piece of the Azure cloud. It's a network space that belongs only to you. You put your resources inside it, and bam, they can talk to each other securely, totally shielded from the public internet unless you decide otherwise.
Now, there are a few core things you gotta know about a VNet. First, it lives in a single Azure region and belongs to a single subscription. You can't stretch one VNet across multiple regions. You also define it with a private IP address space, a range that you get to pick. And maybe the best part, creating the VNet itself, just the container, totally free.
All right, so we've got our big private ocean, our VNet, but we don't just want all our ships floating around randomly. We need to build some structure, some designated harbors and zones. And that, my friends, is where subnets and IP addresses come into the picture. Let's break that down.
So we always start with a really big pool of private IP addresses for our VNet. A common example is something like 10.0.0.0/16. Now that might just look like numbers to you, but that little /16 means it gives us over 65,000 unique addresses to play with. That is a massive amount of space.
But here's the thing. We don't just dump all of our resources into that one giant pool. That would be chaos. Instead, we do something much smarter. We slice up that big address space into smaller, more manageable pieces called subnets. So you might have one subnet just for your web servers and another one dedicated to your databases. This segmentation is so important for organization and, of course, for security. The only rule is that each subnet's address range has to be unique inside that VNet.
Okay, I'm going to throw a number at you. 5. What is so special about the number 5 when we're talking about Azure networking? Any guesses? And here it is. This is one of those gotchas you really need to remember. In every single subnet you create, no matter how big or small, Azure automatically reserves 5 IP addresses for itself. It takes the first 4 and the very last one. So what does this mean for you? It means that a subnet you think has 256 addresses, like a /24, really only has 251 that you can actually use. You absolutely have to factor that in when you're planning your subnet sizes. Okay, let's switch gears to the addresses themselves. Inside your VNet, a resource gets a private IP from its subnet. That's how it talks to its neighbors. But what if you need that resource to be reachable from the internet? Well, that's when you assign it a public IP. The bottom line is simple. Private IPs are for internal chatter, and they're free. Public IPs are for talking to the internet, and they have a cost.
And listen, not all public IPs are built the same. There's the older, basic SKU, which is pretty much open by default. Not great. But then there's the modern standard SKU. This is the one you want. It is secure by default, its address is always static, and it's even zone redundant. Honestly, for any kind of production workload, it's a no-brainer. Just use the standard SKU, period.
So we've built this amazing, secure, isolated network. It's fantastic. But what happens when your application grows? What happens when you need to connect to resources that are in a completely separate VNet? Maybe a VNet that's halfway across the world.
Let's imagine a real-world scenario. Your web application front-end is running in a VNet in West Europe to be close to your users there. But your heavy-duty data processing backend is in a VNet in Central India. How in the world do you get them to talk to each other securely without sending all that sensitive traffic over the public internet?
The answer, and it's a really elegant one, is VNet peering. This technology is, frankly, incredible. It lets you seamlessly link two different virtual networks together. And once they're peered, for all intents and purposes, they act like they're one single network. It's like we're building a private, secure, undersea tunnel directly between our two oceans.
And here is the absolute best part. That connection, that tunnel, is completely private. All the data flowing between those peered VNets stays on Microsoft's own super-fast global backbone network. It never ever goes out onto the public internet. That means you get incredible speed and security by default. It just works. Now, setting up this peering isn't a one-way street. You have to think of it like a two-way handshake. You have to create the peering link from VNet A over to VNet B, and then you have to create another one going from VNet B back to VNet A. Both sides have to agree to the connection before that tunnel is actually open for traffic.
And you've got flexibility here too. If you're connecting VNets that are in the same Azure region, that's called regional peering. But like in our example, if you need to connect VNets across different regions, you use global peering. This gives you a ton of power in how you design your global architecture.
Okay, whoa! We've covered a lot of ground. Let's just pause for a second and do a quick recap of this awesome networking toolkit we've just put together. So, let's review our building blocks. We have the virtual network. That's our private ocean. We divide it up with subnets. Those are our harbors. Our resources get IP addresses, which are like the unique address for each ship. And to connect two different oceans together, we use VNet peering, our secure undersea tunnel. Each piece has a very specific and very important job.
So why do we care so much about all this? Because getting your network design right from the start is the difference between an application that's secure, scalable, and super fast, and one that's a constant headache. Mastering these fundamentals, it's absolutely non-negotiable for building great solutions in the cloud.
So our networks are connected. We've built the highways between our cities. But our job isn't quite done. There's a huge question we haven't answered yet. How do we control the traffic? How do we become the traffic cops on these highways, deciding exactly who is allowed to go where? Well, that's a fantastic question, and it's exactly what we're going to dive into in our next explainer.